Welcome to Samuthra Logic Block 18 Energy Loss in Capacitors. Today, we are going to answer a very common capacitor question using logic instead of memorizing formulas. Here is today's physics challenge. Consider two identical capacitors. One is charged to a potential V, the other is completely uncharged. They are connected in parallel. How much electrostatic energy is lost during this process? Think carefully before choosing your answer. Most students immediately think charge is conserved, so energy should also be conserved. Therefore, energy loss must be zero. Then they choose option A. It sounds logical, but physics says something different. A Samuthra student thinks whenever charge flows, the wire has resistance. Then, according to Joule's law of heating, it produces heat. So, some energy must become heat. Now, imagine two identical water tanks. One tank is completely full, the other tank is empty. Now, connect them using a pipe. Water flows rapidly until both tanks reach the same level. But during this process, energy is lost. That is, you hear sound, turbulence, splashing. Therefore, the energy is lost. Exactly the same thing happens inside a capacitor circuit. Charge flows through the connecting wire, current is produced. Every wire has a small resistance. Because of that resistance, part of the electrical energy is converted into heat. Notice the important physics here. Charge is conserved. Both capacitors finally reach the same potential, but electrical energy is not completely conserved inside the capacitor. A part of it leaves as heat in the connecting wire. Let's verify it mathematically. Initially, energy stored is half CV square. After charge sharing, the potential becomes V by 2. So the final energy is 1 by 4 CV square. Then energy lost equals 1 by 4 CV square, which is 50 percentage. So the correct answer is option C. 50 percentage of the electrostatic energy is lost. Don't memorize physics. Understand the logic behind physics. Every Samuthra logic block removes one misconception.